Welcome back, friends. Yeah, it's another time tunaendelea derivatives of carboxylic acids. Na leo tunaenda kusoma hawa amide. Ambao amide inakuwa ni kama carboxylic acid VC down O then NH2. Naona kuna R. Kwa derivatives of carboxylic acid unaweza kuona ni kama siweki mkazo sana kwa sababu maswali yake yanatoka, lakini swala ni kwamba haya ma derivatives hautakiwi kuyajua sana. Yanatoka maswali ila ni yanatoka knowledge za concept za kawaida sana. Unaona, tofauti na kama maswali yanavyotoka labda kwenye benzene, kwenye alkane, kwenye alkini, kwenye carboxylic, kwenye carbonyl compound, ni tofauti na huko. These are the derivatives of carboxylic acid with the functional group here. So the general formula of the amide inakuwa ni CnH2n plus 1 then ON. Amide can be presented with the general structural formula. Katika primary amide inakuwa hivi, katika secondary amide inakuwa vile one of the hydrogen in the amine group is replaced by R, and the tertiary amide has no hydrogen at all in the nitrogen. Ayupaki and nomenclature of this amide. The names of amide end with the word amide, replacing the suffix oic of the acid. So alkanoic acid kwa mfano neno oic linakuwa ni alkaamide. Alkanoic acid linakuwa oic, ile neno oic linakuwa alkaamide. Unaona, for example methanamide, unaona, methanoic, methanamide, ethanamide, propanamide, unaona, benzamide au benzacarbaxamide, 2-methyl propanamide. Kwa propanoic acid inakuwa propanamide, unaona. Kwa mfano hapa inatakiwa ni nitro bromo 1 2 bromo then 3 4 5 nitro then benzoic acid, so 2 bromo 5 nitro benzamide. In secondary and tertiary amide, one or both of the hydrogen atom on the nitrogen are replaced by other groups. The position of the group is shown by the suffix n followed by the name of the substituent group. Unaona, for example katika nomenclature ya compound kama hizo hapo tunakuwa tuna compound kama N-methyl benzamide, then tunaweza kuwa tuna compound kama N-methyl benzamide, then tuna N-N dimethyl ethanamide, N-N dimethyl ethanamide. Kwa hapa manake ni N-N ni nitrogen, kwa nitrogen, alafu then hapo itakuwa ni N-N diphenyl benzamide, N-N dimethyl methamide na N-ethyl N-methyl propamide. Maana tunataja hizo group tu, N-ethyl N-methyl benzamide. General methods of preparing amide in the laboratory. Kwanza ni acylation of ammonia to form aromatic or aliphatic amide. Acylation of ammonia. So acid required or acid anhydride react with ammonia to form corresponding amide. Acid required or acid anhydride. Hizo group zote za compound tumesha discuss hapo nyuma. So reaction tulizosoma kule kunaenda kuzirudia tena. For example reaction huyo hapo ambayo ni ammonia ni huyo hapa RC down with oxygen, then tuna RC down with oxygen, then tuna chlorine pattern reaction na ammonia na kupata amide. Reaction hizo hapo nyingi tu. Preparation of amide, hiyo ni reaction of acid chloride au acid anhydride with the ammonia. to form secondary amide, acid chloride must be reacted with primary amide. So acid chloride unareachisha primary amide unatengeneza secondary. Unaona pata secondary amide katika reaction kama hizo zinazoonekana. R yule pale ana C double O, then chlorine, then ana RNH2. So tutapata R C double O, then N yule pale hydrogen R, secondary amide. Tertiary amide is formed when acid chloride react with secondary alcohol. Maana yake ni tayari na kumeshaelewa nini ambacho kinakuwa kinaendelea hapo. So when acid chloride react with secondary alcohol, we get tertiary amide. Examples of the reactions zinaonekana kama hivyo hapo. Lakini the second method of preparing this amide, the partial hydrolysis of nitrides. Nitrides ni hizo reaction ambazo zina compounds zinakuwa zina R then zina cyano pale. Tukifanya partial hydrolysis in the presence of water tunapata amide yule pale, partial hydrolysis. Actually this reaction involves the mechanism which is very long, and I remember even when I was studying organic chemistry, this one among the reaction which I hate, and I said if the mechanism of this reaction will appear in my exam, actually nitaacha tu ile swali kwa sababu actually it was very long mechanism. So I will just only explain this mechanism. However, the principles and the basics of showing the reaction mechanism, they are the same. Tunaweza kuwa na R C triple bond nitrogen, then donate hydrogen to donate the lone pair nitrogen to hydrogen, then we form a positive charge in this carbon. After that, we'll have water molecule which will supply electron to this carbon, neutralizing this positive charge. But a positive charge will be transferred to oxygen because it will be donating the electron. Now you can recognize that the principle used to show this reaction mechanism remain the same. In the third step, that the bond between hydrogen and oxygen is broken to neutralize the positive charge in oxygen, releasing hydrogen ion at the free positive charge. This hydrogen ion, which is the free positive charge, acts as an electrophile, allowing the acceptance of electrons from a nitrogen lone pair. So nitrogen donates a lone pair again, and when it donates a lone pair, it becomes positively charged. So the reaction, the molecule now can be seen like this way. From there, what happens that the bond between oxygen and hydrogen can be broken to supply electrons to oxygen, and then the lone pair in oxygen supplying electron to carbon. So bond hiyo patavunjika kusupply electron kwa nitrogen. Naona finally we form this amide and then hydrogen ion there. But the reaction, yeah, tumesha form amide hapo, lakini it's one among the reaction ambayo ilikuwa na mechanism ambayo ni ndefu. So ile ndio ambayo reaction ipo, the partial hydrolysis of nitrides. Unaona bwana. Now examples of this reaction of the partial hydrolysis of nitrides and the categories of amides formed ziko hapo. Number 3, the dehydration of carboxylic acid salt of ammonia. Carboxylic acid salt of ammonia using phosphorus pentoxide. Unaona, kwa hiyo carboxylic acid salt of ammonia. Kwa mfano tunakuwa na carboxylic acid ikireactisha na NH3 tunapata ammonium. Unaona, tukireactisha na ile pale phosphorus pentoxide alafu tukareactisha na heat pale, in the presence of heat tunapata amide ile pale. Actually, these are some of the few examples of the complicated reactions in organic chemistry. Sababu kule mwanzoni reactions zilikuwa nyingi, lakini it's easier to manage them. We have a few reactions, so inakuwa ni rahisi katika kuzimanage. Lakini when we are going further and further, the number of reactions, the conditions and environments for the reaction to occur tend to increase time to time. So when they increase in number, that means it becomes very difficult to remember all of them, and finally to be able to recall them in the exam. For example, hydrolysis of amide. Hydrolysis of amide is only katika chemical properties of amide. Tuna hydrolysis of amide napata carboxylic acid pamoja na ammonia. So we use water and heat in the presence of acidic medium. amide they hydrolyze using water and heat in the presence of acidic medium kutoa carboxylic acid pamoja na ammonia. So we have several reactions for showing the examples. The amide, when amide is hydrolyzed with a strong alkali solution like sodium hydroxide, carboxylic salt and ammonia are formed. Kama tukiwa tuna hydrolyze in strong alkali medium, strong alkaline medium na sio strong acidic medium. Kwa katika acidic medium tutatengeneza alcohol, carboxylic acid. Katika basic medium tutatengeneza salt. Dehydration of amide with phosphorus pentoxide. Amide with phosphorus pentoxide is reduced to alkanenitrile. Inakuwa reduced to alkanenitrile. So unaweza kuona tu tuna R, C double O, then NH2, after na P2O5 heat tunapata ile pale, huyo hapo nitrile yule pale, kwa kureduce amide with the phosphorus pentoxide. But pia tuna reduction of amide. Amide are reduced to amine using lithium aluminum tetrahydride in ethyl ethanoate followed by water hydrolysis. So tunakuwa tuna huyu hapa tuna lithium aluminum ile pale kwenye ether pamoja na water, tunapata pale amine, tunapata amine, tuna reduce amide, tunapata amine. That means tuna remove oxygen. Reduction reaction involves the removal of oxygen to get amine. Other examples of that reaction of reduction is opposite inaendelea, lakini pia kuna reaction with nitrous acid ambayo ni HONO, sometimes it's known as HONO or HNO2. Amide react with the nitrous acid to form carboxylic acids. Unaona, so HONO ni hiyo hapo, unapata carboxylic acid pamoja na nitrogen gas, tuna add pia na water, unaona. Kwa hivyo ndivyo ambavyo amide ina react na HONO, form carboxylic acid. Then from there we have the Hofmann degradation reaction. Hizi ni baadhi ya reaction ambazo kuta ina jina kabisa, reaction ambayo huwa inatoka kama ilivyo. Nakwambia what is Hofmann degradation reaction. So hizi ni baadhi ya reaction ambazo hata kama ukiwa umesahau nyingine zote, reaction kama hizi unakuwa unazikumbuka, unasema I heard about Hofmann degradation. What is Hofmann degradation? Hofmann degradation is the reaction of primary amide with bromine in a concentrated alkali solution. Primary amide with bromine in a concentrated alkali solution at a temperature of sabine to form primary amine with one less carbon. Ndio maana inaitwa Hofmann degradation. Manake tunavunja carbon moja, tunatoa amide, tunatengeneza amine primary ambayo ina one less carbon. The reaction is very useful in organic synthesis of amine. Unaona, so akiwa ni huyu hapa ana carbon pale, kwa tunaenda kutengeneza amine ambayo carbon moja hayupo. Unaona, carbon moja hayupo kwa sababu tumeenda kutengeneza sodium carbonate kule. Unaona, kwa hiyo maana that is very important. Temperature 70, sodium hydroxide, bromine, unaona, one less carbon. Hofmann degradation reaction. The reaction of primary amide with bromine in concentrated alkali. Primary amide with bromine concentrated alkali at a temperature of 70 degrees Celsius to form primary amine with one less carbon atom. The reaction is very useful in organic synthesis. Unaona, kwa hiyo that is Hofmann degradation reaction, and you have the several examples of the Hofmann degradation reaction kama ambavyo uliziona, lakini pia reactions zinaendelea hapo Hofmann degradation reaction. Finally we have a reduction of amide with hydrogen under the presence of nickel. To reduce amide under hydrogen in the presence of nickel tunapata amine. Kwa utaona reaction nyingi za amide reduction hizi tunapata amine. Hofmann degradation tunapata amine. Tutakavyokuwa tunaenda kudiscuss preparation of amine, manake tutaziona hizo zote. Hofmann degradation, reduction of amine, tutaziona amides. Physical properties of amides: boiling point. Primary amide have exceptional high boiling point and melting point. than any other organic compounds because of the excessive hydrogen bonding. The amide groups gives the highest intermolecular force of attraction of all functional groups. Kwa hiyo amide ndizo ambazo zina boiling point compared to all other carbonic compound corresponding organic compound. The boiling point of the secondary amide are also higher due to the hydrogen bonding. Only tertiary amide have lower boiling point since no hydrogen atom is present in the nitrogen. So the amides, the primary and secondary, they have very high boiling points. That is in terms of a boiling point. But also solubility, they must be highly soluble in water because of the formation of hydrogen bond again. This is influenced by these hydrogen bonds. Primary amide have high exceptional solubility than any other organic compound because of the excessive hydrogen bonding. But the solubility of amide decreases from primary to secondary then to tertiary. Primary amide, they are more soluble than secondary than tertiary. That's because in secondary amide we have the alkyl group which is non-polar, so it decreases the polarity of the group and even the strength of hydrogen bonds formed, and hence the solubility of the compound. So this because of the increase in the number of the alkyl groups which replace acid hydrogen atom and hence reduce the number of hydrogen bonds that have to be formed. So aliphatic amide zenye carbon kuanzia 6, they are fairly soluble in water. Benzene carbamide is soluble only in hot water and can be crystallized from hot water. All amide are insoluble in hydrocarbon solvent, yani katika organic solvent ambazo ni non-polar. Toka hapo tuna basicity, yani the degree to which the amide they are basic. Amide they are weaker bases than amine because of the presence of the carboxyl oxygen, which reduce the availability of the lone pair of the electron from nitrogen and makes it not available for accepting the proton. So therefore, the less basic strength of amide is due to the mesomerism and the localization of electron pair known in the amide group. So tukitoka katika amine, the strongest acidic compound katika organic, basic compound ni amine, strongest ni amine. Tunaweza pia tuna amide zinazofuatia pale, lakini mesomerism inapunguza strength, basic strength. So tunasema kwamba while in amine the presence of R exerts the positive inductive effect katika amine and support the presence of lone pair nitrogen atom to accept a proton. The release of electron by R through positive inductive effect activates the lone pair in EOP group and make it very easy to associate. So in the amide, the lone pair is not free to leave nitrogen simply because there is mesomerism, which tend to supply the electrons to carbon and thus causing the positive mesomeric effect, making the lone pair nitrogen less available as compared to how the solution is occurring in the amines. In the coming session, we discuss about the nitrides or the cyanides. The nitrides or the cyanides before we are going to discuss about the amines. So thank you. Kutana kipindi kijacho.